So thank you for being with us today. I'm going to give something of an update of where we've come in the last year or so, but I will include a little bit of material for people who may be more unfamiliar with Scality. Just to start with kind of how we see the marketplace, I think we've all seen these curves that go up 50, 60, 70, 100% a year, and you end up growing to crazy, crazy numbers over a period of years. I think the reality, however, is that this really is happening. 2020 with 40 zettabytes of data in the world is actually only a year away at the beginning of 2020. So we're getting close to these numbers, and who knows where things will go. We've seen a lot of things change in the last couple of years. Obviously, containerization is really taking off. And one of the things we definitely see, the growth of storage is happening primarily in what we call unstructured data that is not in databases, data that are people's files, people's images, things that we deal with as far as data goes every day. And 50% of the growth is actually happening outside of data centers. Obviously, a lot of that's happening on individual devices, on IoT devices, on smartphones. You've heard a lot about IoT, but what we see is the growth of data is really, really continuing as planned, and maybe faster than is planned, and especially in the space of unstructured data. So that's pushed us to really concentrate our energy on handling very large quantities of unstructured data. So I think just some of the things that we consider to be very important. We believe that object storage is going to keep growing in size and popularity. One of the reasons object storage models were adopted was because they were easier to use with very large scale and used directly with applications. And we see applications, things like healthcare imaging, deep learning, that are becoming very, very common place with millions and then billions of files, petabytes of data. Also, we're seeing that there were discussions, is hybrid cloud real, is private cloud real? Today, the world is hybrid. Most of our customers are doing a certain amount of cloud. Most of our customers also are uncomfortable doing everything in a cloud. So we believe that the hybrid cloud is very much in the future. And cloud being a generic term for infrastructure, for storage, for IT applications that are deployed using APIs in an on-demand basis, I would say. And then the multi-cloud is coming on stronger and stronger. And multi-cloud meaning you have a choice in where you place your data, and you're not constrained to just one provider. And I'll talk a little bit more about that with Zinco. But our customers are really uncomfortable with the idea that if they choose an AWS or they choose an Azure, they'll be handcuffed to them for the next 5 years. And it's easy to end up in that situation, and many of our customers are working very hard to make sure that they're not too tied to a single provider. Also, applications on the edge, and that's probably the buzzword of 2018 is edge everything. But we do see a lot of applications on devices, maybe not the refrigerator that orders milk for you, but edge-based devices. Autonomous cars are very growing in that space. And the automobile industry is a place where we're storing huge amounts of data. I think health devices, things of that nature, are growing much more quickly maybe than was expected. And then another piece is that open source is very much going to be a part of the future. A very large amount of the software that's being used in this new cloud world is open source. Obviously, the Linux operating system is for most people the core element of this space. And a lot of the orchestration tools, Terraform, many other kinds of Ansible, many of these tools for orchestration in the cloud space are completely open source. And even many of the public cloud providers are being very active. Kubernetes was a project that Google developed. So we believe open source is the way forward in general, and it's becoming much more mainstream, even in large corporations, including banks, to use open source technologies. So those are some kind of key areas. Obviously, we have other thoughts as well, but these are some of the drivers that are moving the way we're thinking about the future. So I'd like to go through some of the news of our product, how these ideas play out in today's product and the future product. I'll go through a brief presentation of Zinco as well, and we'll have a couple demos. So some of the key Scality Ring news, a brand new user interface, graphical user interface for the Ring technology, and then a smaller Ring configuration, and then we'll go into Zinco. The Ring 7, Scality's Ring 7, which is the on-premise storage system. The architecture of the system presents itself as a logical ring, and so some people have asked us if we're using token ring or some sort of exotic network technology, but it's just topologically it's a ring, and that's the way that the choice was given is a name for the technology. So we have the Ring Supervisor as a central management platform that gives you a view of what's going on the Ring, and I'll go through a little bit of a demo of this interface. But we're working very hard to make the platform more and more usable. Our largest systems have in the range of 200 to 300 servers running on a single platform, so being able to have a global view of everything that's going on is very, very important. So we've worked a great deal on improving this interface. We've also included interfaces that was in a sense missing in the past from the Amazon S3 component. We have very strong support for Amazon S3's API, most all of the protocol features, as well as the Amazon IAM, the Identity and Access Management platform. It's really a role-based access, very sophisticated role-based access platform. Now, both of those have very sophisticated APIs, and we do our very best. You can actually use Amazon's tools and point them at our technology and use Amazon's SDKs, their APIs, tools to talk to our system and to control our system. But Amazon has a portal, and our customers didn't have a portal. And so that has been a very strong request for our customers to have a portal that they could use Scality's technology on premises like they were used to doing with Amazon's in the cloud. And I'll go through a little bit of this. So this has been quite a bit of work this year that we've invested in making sure that people have the same kind of portal experience on their own platform. And this is all white labeled. This is, in some ways, most usage of object platform happens through APIs. But the reality is, until people understand what they're doing, the adoption, it tends to be very low. And this has been very helpful for getting large, for instance, banking customers to get adoption. So that includes as well a browser, and I'll have a little bit of a look at the S3 browser as well. So let me just jump in to the Ring demo. Hopefully my screen won't betray me here.
Just one question.
Sure.
To the S3 compatibility, because S3 is a standard, let's say a de facto standard given by Amazon.
Right.
To the market. So, and a lot of vendors claim they are 100% S3 compatible, but I think with anything beyond AWS can't be 100% compliant.
Exactly.
So how do you deal with this issue?
So I very much agree with the statement. 100% compatible is market speak. It's just impossible to be 100% compatible. There are certain functionalities that are very, very Amazon specific. And we've mostly been driven by our customers' demands for certain functionalities. IAM is a functionality that's very, very rich and very helpful for large enterprises. It allows enterprises to have their users, their employees, use a platform like this without creating a user account for every person in the company. There's a tool that's called Federated Identity Management. An Active Directory is used. So that was a functionality that AWS had that we felt was very important, and that's what our customers told us. There's some things like being able to have someone else pay for an access to the system that are very Amazon specific, and we haven't even tried to develop those. But most of the policy features, we found that our customers really need them. Probably the most notable recent feature was a listing feature that was called version 2 listing, and it's the most significant change that's been made probably in the last I would say 2 or 3 years. And the V2 listing is a functionality that was always there, but that has been modified and changed and produces different outcomes. And that one broke compatibility, and we've actually implemented that one this year. And typically we'll work with an ISV. We have a program with ISVs where we'll set up an S3 interface and that they can test against it. One of the things that's been very helpful as well that we're taking advantage of, our S3 protocol connector is completely open source. It runs in a Docker container on any laptop, and we've seen crazy numbers of downloads of that Docker, millions and millions of downloads. And the best we can tell, it's been used in continuous integration interfaces for third parties testing their Amazon compatibility. Because it's a very easy tool. Rather than spending money sending data to Amazon, you deploy this in your QA environments. And so we've actually met customers that were Scality compatible before they were Amazon compatible. And that's something we're very happy to promote in the future. So, but yes, it's an interesting question how long this will go on like this, because it is very much a de facto standard, and I'll talk a little bit about how we're using that in Zinco. But there's no promise that tomorrow Amazon will completely break things. And we're just recently working with a customer who does things incorrectly, completely in disobeying what Amazon says they should, and it works on Amazon.
Are there any requests coming on CDMI from customers?
No. We still support CDMI in our technology. We actually use it internally. In a sense, we don't even refer to it as CDMI. We refer to it as an HTTP interface to the technology. The overhead of talking CDMI to a backend is so heavy that most customers don't use it. But okay. That's sad news for the SNIA, but it's just the way it is. So let me.
By the way, we do have a SNIA representative, obviously, here. Torsten is representing.
I mean, we put our hearts and souls into making CDMI work. I think we may be one of the most industrial CDMI implementations in the world, and we use it all the time. But the customer demand is pretty much non-existent. So here's a live Scality platform. This is we have an S3 interface and a file system interface on the same platform. We have Scality has what we call a data ring and a metadata ring. The metadata ring is used for all of the file system structure, and it allows us to scale the platform. And then you have 10 different servers and 36 drives, hard drives for storing data. You have a look at the total capacity of the system and forecasts for how it's growing, the number of objects. This is a pretty empty platform, and how the capacity is trending over the last period of time. You can dig into an individual server. You can see you've got overall information, then information about the hard drives that you see on the server, information about the kinds of network interfaces, all of the details about the system. And then we use Grafana to present usage of the system, and you can see the number of operations, the latency and the bandwidth, the loads, CPU usage of this specific server. So you can dig into each one of the servers, and this system has a total of 6 servers, each with they actually have 2 hard drives and 1 SSD, and we can split those up into separate groups, and it shows that the data that's stored and the data capacity that's free on the system. You can look at the S3 interface. It gives you a notion of the percentage of on time and the kinds of response codes that you've been getting across the system and the global health there. It's one of the newer features of the system. This is the very most recent version that just came out a couple weeks ago. Doing volume management, you have configuration groups that we've added that allow you to have configurations for the different protocols that you can group together. So we have NFS, SMB, local file system, which is a local fuse mounted file system, and different connectors from those. And each one of those, we also have the number of operations per second. I ran an IO zone on the thing just before I came up here, so there'd be a little data on the screen, but you can see the number of operations per second, the latency of the global operations on the system. And then we have some additional access to the system. We have an advanced monitoring tab here that takes you to Grafana dashboards across the whole platform. Many of our customers use this interface, or they implement this in their Grafana environments on the system. If you go look at one of the connectors here, this is actually an SMB volume. There's no disks on that volume, but you can have hardware information about the particular server. And this gives you load averages, for instance, on a very specific connectors. The connectors provide file system protocols built on top of the system. We're getting very interesting performance. We have a single SMB connector gives up to about 1 gigabyte of throughput for a single connector, and we can add more and more connectors onto the system as the system grows. This particular system has 6 storage servers, 3 connector servers. We can also run the connector servers directly on the storage servers, and we can also we're actually running S3 on top of the storage servers. So then we have an S3 console that I mentioned. This is the S3 console that gives you access. Here you have, this is the console interface to the IAM system. So we have groups of users. We have for instance, I've created a full access group and a read-only group. If I have a read-only group, I put the salesman in the read-only group, and the full access group, just the owner of the system has access to. This allows us to create policies. These are IAM policies. You can edit the IAM policies, and you'll see they're exactly like AWS's IAM policy that you can modify on the system. The IAM functionality of Amazon is very, very sophisticated, and we've implemented just about the entire feature set. Then we have accounting metrics that are very important. This is at the account level, and then each individual user has their metrics. You see the total storage consumed by the user, and then different kinds of requests by operation type that the user's been making on the system. You also have a bucket view of the system, and this particular platform has 2 buckets. Bucket A and Bucket B, and Bucket B has a significant fraction of the data. You have the bandwidth in and out of the system, and when the buckets were created, and information about the system. So this allows users access for billing information. The platform is being used both for public platforms and for private enterprise-based platforms. And if I go back over here, we can have a look at the S3 browser. Here we have those same buckets. Have a look at bucket A. And you can see objects in the bucket, and you can have all of the information about the buckets. You can, all the tagging information, I'll talk more about that when we talk about Zinco. Cross-site replication is not activated, whether you want the data to be public. So these are typical pieces of information that you can update via the API, but you can also do all of that through the browser. Now, the reality is most customers do not use this
I was about to ask, I mean, if you have to go through every file or every object and then you say, okay, this is cross-regional replication allowed and stuff, is it possible to do that for, let's say, a bucket itself?
Right.
Because otherwise,
absolutely.
you go nuts.
Absolutely. So this is, in some ways, this interface is very rarely used by a system, someone using a platform like this. Typical Amazon buckets with applications are running in the millions of objects, even up to 1 billion objects is not unheard of on the Amazon bucket. So you're typically not clicking through for these things, but the reason we developed this interface was we have a new customer. They said, okay, now we want to use the platform, and you say, well, here's the API. And they're probably about a month from being able to actually interact in a healthy way with the platform. They try the API and they say, now, did I get that right? And this is a very good way of being able to say, did I tag that object? Oh, I didn't tag that object. The tag isn't right. So yeah, this is not the way you use an object storage platform. And I argued that you didn't need this interface for a number of years, and I've stopped arguing because people love to be able to, it's like Windows Explorer. You can do it from a command line. You can wander around and change all your files, but Windows Explorer.
One of the things that a customer wants is nice to have if someone wants it, but it's not really convenient for use. I would see it that way.
Right. So there's little we can do. I mean, you can do certain things on a bucket level, but it's really for getting people up and running with this kind of a platform. And most of our customers are not using this particular interface, and I think that's true of AWS as well. People become familiar with the platform through this kind of an interface. Now, I would say that the console interface, especially here, this is the kind of thing you do, maybe once a week, and you maybe have 10 employees. Now, some people have 10,000 employees, and they have to use an API. Typically, what we see is people that use this platform for maybe a small collection of applications. They might be using a backup software like Rubrik is the hot backup software right these days with S3. So they deploy Rubrik and they deploy Cterra or some other file sync and share. And so they only maybe have 5 or 6 AWS S3 accounts. They would use this interface is great for them because they don't have to learn the API. But if you have, for instance, we have banks that their teams of developers are using the platform. And so to provision a developer account, they wouldn't want to use this interface. They want a developer to get their account automatically through their provisioning system, and they use the API. So that's kind of how the two worlds work. But I would say that in general, this browser interface is really a very good way to come to understand the way the platform works. I think the whole question, S3 doesn't have a hierarchy of files, and people really struggle with those ideas. So those are some of the things that this has really been helpful to get customers up and running with the platform. We've had customers that have deployed S3 and almost quit because their employees wouldn't use it. So this is kind of a foot in the saddle, if you like, for those people. So that's. The rest of the interface for management, people do use that much more extensively. Just talk briefly about the 3 storage server system. Oops. This was a strong request from our field, the customers that also the partners that we're working with, HPE, Cisco. When we first built this technology, the first servers we deployed had 10 or 12 1 terabyte drives in them. So we had 100 terabytes in one servers. One server at the most. There were 6 servers with 600 terabytes. You were looking at 150, 200 terabytes of usable data for a simple platform. Today, we're selling servers that have 60 10 terabyte drives in a single box. You're looking at well over a petabyte of data with 6 servers. You're actually looking at being able to do a petabyte of data very easily with 3 servers. So the economics of wanting to start with a 200 terabyte platform and needing 6 servers were very complicated. And so there's a lot of reasons that the platform is happier with more servers. The more servers you have, there's nicer ways of spreading your data out. You have more durability and protection, more things that can fail on the system. But most of the characteristics are retained on a 3 server platform. And there's great, you see the almost 50% savings on a 3 server platform at 200 terabytes. And it's a way to get started on the smaller platforms that indeed are not massive scale, but we see customers starting sometimes in the 200, 300 terabyte range and growing to the massive scale over time. So we keep the attributes of the system, the ability to be upgraded while it's online, the ability to lose an entire server and stay online. So this was just released 3 months ago or so. So we have some deals in flight right now, but we'll see over time how popular this kind of low-end offering becomes.
How do you price that?
I'm sorry?
How do you price it? Do you price it like
The same way. And basically the path to 20 petabytes is the same. Over time, they'll add servers to the platform. So it's the pricing is either hardware-based, hardware lifetime, hardware-based, or it's perpetual license, quantity license. So a few words about Zinco. It's currently at use at Bloomberg, and Bloomberg is really one of our customers. We were thinking about this idea. We already had them working on other projects and started talking to them, and they had a very interesting use case that I'll talk a little bit more about. And so they've been very closely involved with us on the design of the technology. So Zinco is a Japanese word that basically means a celestial fox. So it's a fox with magic powers, if you like.
Japanese comic, isn't it?
What's that?
It's a Japanese comic.
It's a comic.
Yeah, it's a Japanese comic word. Yep. So we ask ourselves, what do you need to manage object-based data at a very large scale, but also across multiple environments? And one of the challenges is having a single global view of everything. So that's kind of the fundamental idea. With Zinco, you can have a single global view of a disparate storage environments. You have a unified interface across the platform, and indeed we chose AWS's S3 as a default protocol so that you can talk to all the different storage platforms with the same interface. But when we did that, we didn't want to lose the power of the native formats. If you push data with an S3 interface to Azure, you don't want to lose Azure's AI capabilities because your data is stored in some strange format.
How would your system cooperate with general multi-cloud operating or control systems? For example, like Nutanix has introduced Cloud Suite or something, cloud control or what, or others will follow.
Right.
Will have. So, do you work below these, or how do you correlate?
So we're working on that. In some sense, you have a number of these multi-cloud orchestration tools that have come out, and most of them concentrate the energy on the compute and the network components more than on the storage. So the ideal situation would be that we work together with them, and we're working on exactly how that would look like. Our perception is our expertise is object storage, and we do feel like one of the biggest challenges, and SAP actually did a study recently that indicated that one of the biggest challenges of multi-cloud is how to get your data moved around between the clouds. If you have a petabyte of data, pushing it one place or another, and Amazon and others have come up with some very exotic strategies. They send a device to your office and carry it on a truck. But it's really one of the hardest problems. But in answer to your question, we're working on it. And I think a lot of those people haven't done much work on the storage piece yet. And orchestration is not our business. So hopefully we'll be able to work out some. There aren't any really standard interfaces between the two, but we're talking to several of them. HPE has one called OneSphere, and we're talking to those people and some others about the idea. So same interface, the AWS interface, the native cloud format. So if you push your data to whatever public cloud, you can use their tools to work with your data. So if it's Elastic MapReduce on AWS, or some of the AI tools on Google, or Lambda functions on one of those are things that you can do natively. And the other component is policy management, pushing data from one place to many, doing lifecycle management across data, expiring data across diverse environments. And then the fourth component is metadata search. That adds something that isn't available in S3, which gives you the ability to metadata search across single buckets, or long-term across multiple buckets, across the entire pool of storage. So being able to search metadata tags, being able to search files by size, I'll show you a little bit what that looks like. So the combination of those four functionalities is really what make up Zinco. So just a quick review. I said most of this, but standard application interface is the Amazon S3 API. Frank already mentioned we support our Scality ring backend, Amazon S3, Azure, Google, DigitalOcean, and Wasabi right now. Obviously, platforms like Ceph, Swift, other private cloud environments are things that we're looking into. It's not me. For moving the data around, we have one-to-one replication, very much like Amazon. It's cross-region replication, but we also have one-to-many replications, replication on the system, lifestyle exploration, and we will be adding this next spring, lifestyle transition, being able to transition from one cloud to another after 3 months, for instance. And you can use user-defined metadata, system metadata, any of the metadata associated with the system, including tags, to do searches.
We will see architectures where massive amounts of data will go back and forth between edge, close to edge, kind of whatever facilities, maybe edge data centers, special kinds of edge controllers, whatever. And there will be changes also in that data because it will be filtered or pre-processed or whatever. And will go back in maybe even a different format.
Right.
Or as an impulse to do something or something.
Right.
So how will you deal with that situation?
So I'll show you a couple slides of what we're thinking in that there's two ways that we can include Zinco with your data. One of them is for Zinco to be the master. You push your data in through Zinco, it distributes it to the cloud. There's another way that we use data with Zinco, which is what we call out of band. And we use the notification functionality of the different clouds. For instance, an AWS bucket that you're pushing data into, we get notifications, and then we can choose what we do. If we only update metadata and just become aware of where the data is, and then you can retrieve it through Zinco's S3 interface should you decide to, or we can also bring the data back in-house. So the idea is to make it completely flexible so that you can choose. If my data has gone through a transition, maybe I can just note the transition and not actually move the data back and forth. We have customers in the media space. I'll show you a little bit about Bloomberg, are pushing data to the cloud. We have another customer that wants to do all of their work in the cloud and only pull back very specific data that is a result of some of the workflows like you described. Things like one of the things becoming very popular right now is doing speech to text on video, and then pulling down, for instance, only the text piece. And then you can search the video should you decide you need to, but you can search the text locally or search the video. So those are some applications that we've actually got other media companies. It's almost the mirror image of this pushing data into one place. You bring only the data that you really have to have on premise, and so those are that's the way we're thinking about that right now. So this is the media workflow that's we've been working on with Bloomberg, and the basic idea is you have media assets, which are a collection of video files, of metadata files, of everything that they need. For instance, for an event, obviously the Strasbourg shootings would be a media asset, an event in time. So they push the collection of data up into multiple public clouds so they can distribute it in different regions of the world. And what they wanted to be able to do is to be able to push with policies to very specific public cloud environments, different places in the world, and be sure that the data was there and be able to delete the data when it was no longer needed. So this has a private multi-cloud component, and also the ability to do the federated search was very important for those assets. So this is one example of a usage that's being more aggressively developed. And then, like I said, almost the mirror image where the data assets are coming in on a public cloud, they're being updated on a public cloud, and we only download the things that have to be put out through traditional broadcast in the media space. So this is kind of the very high-level vision of what our plan is. This is what I call Zinco in 3D. The system runs in a collection of Kubernetes containers. So you can run it in a variety of environments. We're working on compatibility with these environments. Things like Redshift, Cisco Container Cloud, Google's cloud platform, and Metal Kubernetes is our environment that you can, if you don't have a Kubernetes environment, you can you can use our Metal Kubernetes to deploy a simple Kubernetes environment just for running Zinco platform. So it runs on many platforms. It has many sources of data, be they AWS, Azure, all of those we mentioned. We're working with Alibaba. Hyperdrive is a future project that we're working on. I'll talk a little bit more about NAS and traditional file systems, what we're doing there. And then you can push to all those same kinds of destinations. So whichever one of these sources, whichever these targets, the goal is to have the same collection of functionality, the same S3 API, the lifecycle management, the replication ability, the out-of-band updates, and the metadata searcher, irregardless of which particular platform you're running on, irregardless of which your source and destination targets are. The nice thing about that is, depending on your workflow, if most of the work is going on in a cloud, you can run Zinco in the cloud. If much of your work is going on premise and you're just pushing a little data off-site, you can run it on premises. So that's the idea. You put a Zinco instance there where it makes the most sense, where even you can change the economics by which way you're pushing data. Obviously, pushing data at AWS is free, pulling it out is very expensive. And this gives you ability to make some choices about where you're pushing and pulling data from and to. So this is something we actually didn't really think about when we designed the product, but it's really, we found it very appealing to our customers. And what we see, a lot of companies that are making a transition to object storage still have a large collection of traditional NAS platforms, of individual cabinets full of data. And so the idea is to be able to take your data on this journey to the object in the cloud world in as smooth a transition as possible. So the idea is that Zinco can examine the data in a NAS and do several things with it. The first thing that you can do is just import all the metadata into Zinco, and it becomes metadata searchable, browsable from an object-based interface, and you can retrieve data using an S3 interface from your traditional NAS without moving data anywhere. Then all of that data will become a target for lifecycle management for any kind of transitions. So data in a legacy NAS can be pulled out, pushed into multiple clouds, pushed onto an on-premise object storage. Or you may decide that none of the data is useful at all, and you could, once you've pulled out anything that matters, just shut the machine off and dispose of it. But that way, legacy systems can really become part of an entire sort of a new world, if you like, cloud environments where the data is available and searchable from an API interface and consumable from an API interface. And I talked with the CTO of Société Générale a couple weeks ago, and they're very excited about this idea because they're wanting for their whole company to move to this cloud-based model, but they have a lot of legacy data. So this is a way of helping do this journey to this new world. So let me give you a quick demo of Zinco. This is a demo you're certainly welcome to do yourselves. So the place to go is zinco.io. And you've got a little tab over here that says Try Zinco. I've cheated a little bit. I've already done an installation. But the system allows you to do basically what's called a sandbox installation. This installation is actually running on AWS. What you're seeing here is what we call the Zinco Orbit portal. This is a management portal for Zinco. You can also deploy the entire Zinco environment on an on-premises Kubernetes cluster or in a cloud Kubernetes cluster, and then you manage it through the Zinco portal. So this is just a sandbox system, but you can deploy this at scale and use this interface to manage it. So I've been given a certain amount of capacity that you can use the system for 24 to 48 hours and then it's deleted. You have the capacity that's free. I haven't used much. It looks like it's 5 gigabytes that you get for a temporary basis, and I've got 59 objects in the platform, and I've got the usage of my system hasn't seen a lot of activity in the last 24 hours. So that's an interface a little bit like the other one. What I have here is actually storage locations. I have at Azure storage set up with Microsoft Azure Blob Storage. I have a Google storage, and then I have US East is the default S3 storage, and I have a little bit of storage locally, and that's so right now you can see the interface to configure new storage. If I add new storage, I give it a name, and here I've got the different kinds. So I've got S3, DigitalOcean we talked about, Google, Azure, Scality Ring with some different connectors, Wasabi, and the local file system. So this allows you to add new storage locations. I've already configured another with my credentials on this system. And we also have a browser. There's obviously the S3 interface. We have a browser interface. I have created a bucket. It's called local only. That's got some data in it, and then three-way that we'll have a look at later. So different settings you can create. I've got a few hours left on my sandbox here. I can create a new users, and we've got, for instance, create a new user. Here is his Amazon key, if you're familiar with those, and I can show Frank's secret, and it's clear text only one time, and then if you need a new secret from you. So this is the standard AWS method. One thing that we've done, which can be useful, you can actually download the profile for a local system like CyberDuck. I've actually used that profile here on CyberDuck and installed it, so I have access to my system.
What is CyberDuck?
CyberDuck is It's an well, it's actually, it does a number of protocols. It does FTP. It's a friendly local interface to an S3 platform. So it's a browser and it's commonly used, again, very much like the web interface to help people understand how the whole thing works. Individual users will tend to use this. So here's my local only bucket, and you can see I have contents in my bucket. And I've got a photo of Steve Ballmer, different things stored in my bucket. So I've also got another bucket here that's completely empty, three-way, and I'll use that bucket in a minute. So anyway, you have the traditional ways. This is accessing the platform that we set up with Zinco via standard S3 API. What I'll do, I'll set up replication here. I don't have any replication set up yet, so we'll call this. Spell it right. We'll call it Munich. A source bucket. I have my three-way bucket that I haven't used yet. You can potentially choose a subset of your data. We'll just leave it as it is. And I'm going to add both Azure and Google and save that. So now I have a replication scheme where I can store my data first locally and then push it onto two different public clouds. So if I were to have my three-way bucket here, pick up some interesting file or two. We'll put Steve in there as well. What happened there? There we go. And so I've put those files on the system. Now, obviously, if I go over here to my browser and three-way, we'd hope to find the files. If I look on my S3 account, I've got a sub-bucket called three-way, and those two files have showed up on the Google platform. And then if we switch to Microsoft Azure platform, what you're seeing here is Microsoft Azure's Storage Explorer, which is basically the same idea as CyberDuck. It's a sort of a fat client locally, using this instead of the Amazon's web interface. Again, very often these interfaces would be accessed using an API or an SDK rather than these tools. And in my folder 3D, you can see that it replicated from the local system to the two other public systems. So this is the basic idea of Zinco. And if you add the last thing that I can show you about Zinco, which is interesting, is the search interface. I can search things like all the files that are PDF. I can search all the files that are larger than a megabyte, or 10 megabytes, or 100 megabytes, or all the files that are larger than a kilobyte.
Do people search like that?
So the people can't today. People can't today. There's no way. The only way you can search a bucket is to download the entire listing and search through all the data. The usage that it appears to be one of the most interesting usages is to be able to tag data and then search the tag data. Now, tagging in AWS is a bit of an oddity. If we take an example here, you have information about a file. There's no tags, and there's no special metadata, but you're allowed to create things like these traditional HTTP kinds of metadata. But when you put HTTP metadata with an object and you push the object, that data becomes static. To modify that data, you have to push the object again. The tagging data is very dynamic. You can change it all you want. And so it makes it a very interesting thing to be able to do tagging of data, for instance, the national origin of the data, or I've just included a couple of very dumb examples here. Tags color equals pink. I tagged one of my objects pink, and I have a 3D alligator JPEG that appears, and the color has been tagged in pink. If I tag money, I get Steve Ballmer. If I tag mood, which is another tag, Goofy, I get Steve Ballmer as well. So you get the idea. You can tag data. This is very, very appealing to people because you can tag data after it's already been stored or when it's being stored. And I'll show you an example of a very interesting way to use this. And then you can search the tags. Now, how much the search interface is used is a good question, but it's a bit of a work in progress. What we've done is you have the standard S3 interface that has no search capabilities. But what we can do is these tags, the kinds of searches that are being done here, if you have things like the word report, let's see, let me choose one of these here that's extension PDF, things like that, tags like that, or searches like that, you can actually put those as part of a query request that looks just like an Amazon S3 GET with a little different additional data in the same authentication mechanisms to S3. So we've done our very best not to break Amazon's protocol in doing this, but obviously Amazon doesn't support a query interface. So we'll see. But the appeal is very strong across our customer base to be able to do this.
Could you also search content? No.
So we've set it up just to search for tags right now. There are tools to search for content, but typically the way content search is done today on a platform like AWS is to use Elastic MapReduce. And you can actually use a tool like Spark to do text-based search in an Elastic MapReduce. But that's sort of an add-on subtlety to the model. So Fred is keeping me honest on time, so I'll move along. Just some thoughts about the future of the technology. Today, the Scality ring is very much our on-premises platform. I think Frank mentioned some of the numbers. We have file systems with over 20 petabytes of data. We have one SMB, a Windows share that's over 20 petabytes in size. It may be one of the largest Windows shares in the world, maybe the largest Windows share in the world. And a platform with over 2 billion files in a single file system. So a single global namespace with over 2 billion files. We have object platforms that are running over 300 billion objects, and platforms that are running in the range of 300 servers. And like I mentioned before, we're having file systems that have single stream performance of around a gigabyte per second with a single connector. We have, today we support numerous multi-site versions. You can deploy Scality on a single site. You can stretch it across 2 or 3 sites. We have a system here in Munich that's stretched across 3 different sites, and you can lose any one of the 3 sites and still have access to all of your data. Very, very reliable system. We can also geo-replicate systems between an active-passive model. So we have a lot of functionality today. It's really, the technology of the ring is very much well designed for a corporate S3 cloud that's being used by a large pool of users, or a big and fast file system for applications. So where do we go from here? I think one of the things that we're going to be working very hard on this year is to marry the native file system and the native object systems together with Zinco, so that we can have all the functionality through the same user management, the same interfaces. Zinco was developed, we absolutely wanted Zinco to be able to live alone. It didn't need to have Ring, but we really want the two of them to communicate and cooperate in a very healthy fashion. So we're doing quite a bit of working on this, because we've really seen this transition, I'd say the last 12 to 18 months, where the hybridization is really happening. People are not going to be all on premises, they're not going to be all cloud, they're going to be some of both. So the S3 and our scale-out file system, excuse me, can both, could I have a little water? S3 and the Scality file system can both feed Zinco directly and do these out-of-band updates that I mentioned, and you'll be able to enjoy a consistent S3 interface across the two. So that's one of the things, creating the family between the native object file system interfaces and Zinco. And then a little bit more of the vision for Zinco. It really, I think one of the most significant things we're going to be doing is really working very hard on Zinco for these, I already mentioned this, for existing NAS data. So this is a mock-up. It's not, you won't find this on the public Zinco interface. But as a storage location, what you'll end up with is a location type that would be an NFS server, an SMB server. The host and location, the export path, all of the details of how to access that NAS will become a location, a peer location with all the others on the Zinco platform. And then in the end, you have this view. What you see here is a mounted volume with the NFS interface here, and then you have over there the S3-like view of the same data. So both file system view, S3 view of the same data set. Now, one of the things that we think is very interesting with this, we talked about include metadata search. One of the interesting things you can do is you can feed metadata to the system and take any group IDs, MD5s, anything you find interesting about your file system data, included in the metadata, and it can be used for tagging of the system. You can also imagine workflows where you run the data. We've actually done this. Run a video through Microsoft's tools that tag a video with all of the things that you see, man speaking, nature scene, things like that, and then it automatically puts tags in the data. So this is the idea around the NAS data, being able to already prepare the metadata. And to complement that, we're working on a workflow engine that will allow you to do things like Lambda functions as you're cycling data in and out of the system. So using Amazon's or Google's or Azure's, whoever's Lambda functions that can do things like transcoding of data as it's being pushed into a cloud or pulled out of a cloud, being split across multiple clouds and deduping it to one cloud. We have algorithms we're working on to be able to erase your code and send parts of the data to multiple sites to increase the data durability. And so in the end, we have this workflow manager this is all open source. Almost everything you see about Zinco is open source except the portal platform is operated as a service. And the idea is to provide a framework that people can develop their own modules for the workflows. So being able to do all kinds of different Lambda functions or transcoding or decoding of data. There's a lot of information available in files that then can be put in tags and used for searching. That's a quick view of what we're hoping for the future.